Okay, today in geometry, we're looking at our last section of chapter 3 before our chapter 3 test, which is 3.6, proving theorems about perpendicular lines. Our very first theorem, theorem 3.8, says if two lines intersect to form a pair of congruent angles, then the lines are perpendicular. So we have this picture over here, and we can say if angle 1 is congruent to angle 2, then H is perpendicular to G. So if the two lines intersect, form a pair of congruent angles. So in our picture, we said angle 1 is congruent to angle 2. Then we could say that line H is perpendicular to line G. Remember that perpendicular means they form right angles. Okay. The next theorem, 3.9, says if two lines are perpendicular, then they intersect to form four right angles. So in this picture, we could say if A is perpendicular to B, then angle angle 1, angle 2, angle 3, and angle 4 are right angles. So we could say that all of these are right angles. So they would each have a little square. Our next theorem, theorem 3.10, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Remember, acute means that they are less than 90 degrees. So in this picture, we could say if line AB is perpendicular to line BC, then our two angles in the picture, angle 1 and 2, so then angle 1 and angle 2 are complementary, which remember means that they would add together to equal 90 degrees. So we would have a little square there. Our next theorem, 3.11, perpendicular transversal theorem, says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So in this picture that we have lines H and K, and then line J. We could say if line J, so if J is perpendicular to H, and H is parallel to K, so if we marked that in this picture, J perpendicular to H, and H parallel to K, then we could say that J is also perpendicular to K. Let's look at another theorem on the back. So theorem 312, lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So in this picture, I have lines M, N, and P. So I could say if M is parallel to P and N is parallel to P, then that's enough to tell us that M is parallel to N. So we would have these marks there. Then we would know that these two are parallel to each other. Okay, so now we're going to see how we can use all of those theorems. So this first set of problems, it wants us to write the theorem that justifies the statement. So number 1, they give me this picture, and it says angle 1 and angle 2 are right angles. So angle 1 and angle 2 are right angles. This was theorem 3.9 on the front of our notes. It says if two lines are perpendicular, then they intersect to form four right angles. So this is theorem 3.9. This is an example of that. Number 2, they give us this picture, and it says R is perpendicular to S. So that is the very first theorem we talked about, theorem 3.8. So you see that they have angles 1 and angle 2 marked congruent. Theorem 3.8 told us if two lines intersect to form a pair of congruent angles, then the lines are perpendicular. And then the next one, angle 1 and angle 2 are complementary. This is the picture that they give to me. This was theorem 3.10 from the front. Theorem 3.10 told me that if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. All right, so now next set of examples. It says if lines L1, L2, and L3 are parallel to each other, so I can go ahead and put my arrows on all of those. And line K is perpendicular to line L1, so this is a box. What is the measure of angle 2? Remember that we have this theorem that tells me that if the transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. So I know, therefore, our theorem, which was Theorem 311, then I could say that K is perpendicular to line 2. Oh. And K is perpendicular to line 3. So I know that these are all perpendicular. Therefore, I can say that angle 2 is also 90 degrees. Next page. This page is a lot like what your homework is going to look like. So it says in the diagram, R is perpendicular to S and R is perpendicular to T. Determine whether enough information is given to conclude that the statement is true and explain your reasoning. So based off of what they told me, R perpendicular to S, R perpendicular to T, then we have that theorem that tells me, so therefore we know that S is parallel to T. Okay. So A says angle 3 is congruent to angle 5. So 3 and 5, they're both marked 90 degrees. We know that R was perpendicular to T and R perpendicular to S. That made R the transversal. 3 and 5 are corresponding angles. So yes, we have enough to conclude that the statement is true by corresponding angles. The corresponding angle postulate. B says angle 4 is congruent to angle 5. Again, since we know that S and T are parallel, 4 and 5, what kind of angles are 4 and 5 out of our special pairs with transversals and parallel lines? 4 and 5 are alternate interior angles. So yes, we know that those are congruent. So yes, by the alternate interior angle theorem. And then it says angle 2 congruent to angle 3. Angle 2 is up here on line U. 3 is on line T. They both touch R, so if R could be a transversal, do we know that U is parallel to T and that R is perpendicular to U? We don't know that. It's not marked, and they did not tell us that. So therefore, I don't know that those make any special angles, so I would say no, not enough information given because we don't know that R is perpendicular to U or that U is parallel to T. Okay. Now we're going to look at some examples where we have to find the value of variables and explain your reasoning. So number 7, it says angle EFG is congruent to angle HFG. So 5x, we want to know what is 5x. Together, these make up a straight line, don't they? So we know that together they have to equal 180 degrees. They're supplementary. If this one is 5x and this angle HFG is congruent to that, then that is also 5x. So the equation that I could write would be 5x plus 5x equals 180. Combine my like terms. So 5x plus 5x gets me 10x equals 180. To solve for x, I need to divide by 10. So I get x is equal to 18. It said, explain your reasoning. Well, what did we use? We used the definition of a straight angle. So this is a straight angle. Or we could have said supplementary. We knew that the two of them together were supplementary. Number 8, it tells me AB is perpendicular to AD. So that tells me that I have a 90-degree angle there. So that means that angle BAC and angle CAD are complementary. So that means when I add them together, they would equal 90. So my equation would be 36 plus 9y equals 90. We want to get the y by itself. So the first thing we're going to do is subtract 36 from both sides. So then I get 9y equals, so 90 minus 36 gives us 54. I need to get the y by itself. So it says 9 times y. So I want to divide both sides by 9. So I get y is equal to 6. Explain my reasoning. Definition of complementary. The next one, it tells me that ray KJ is perpendicular to ray KL. And it tells me that angle JKM is congruent to angle MKL, and they have labeled them both Z. Perpendicular tells me that they are 90 degrees. So I know that Z plus Z has to equal 90. There's my equation. Combine my like terms. So Z plus Z gets me 2Z equals 90. And then when we divide, Z equals 45. This one will actually get a degree sign because the Z was the actual angle itself. Again, we could use definition of either right angle or complementary. Next set of examples. It says, use this diagram that they give to us. So we see that R is marked perpendicular to M. R is also marked perpendicular to N. S is marked perpendicular to N. T is not marked at all. And so 16, it says, is R parallel to S? Well, R is perpendicular to N, but S is also perpendicular to N. And remember, we had that theorem that said if they are perpendicular, if two lines are perpendicular to the same line, then those two lines are parallel to one another. So here I could say yes, because both R is perpendicular to N, S is perpendicular to N. Therefore, we had that theorem that said those two lines are parallel. So R parallel to S. 17 asks, is M parallel to N? So now it wants to know, are M and N parallel? So I look and I see that M is perpendicular to R, but so is N. So again, this is yes, because both M perpendicular to R and N perpendicular to R. Therefore, M is parallel to N. They're both perpendicular to the same line, so they have to be parallel to one another. The last one asked me, is R parallel to T? So this line over here parallel to this third line over here. In the picture it sure does look like it, but remember that we cannot assume anything like that. We cannot assume parallel lines. We cannot assume right angles. Remember, all of those things we cannot assume. Nothing is marked. I see that R is parallel to or perpendicular to M and N, but T is not marked perpendicular to either of them. So do I have enough information to say that R is parallel to T? No, I don't. I know R is perpendicular to M, R is perpendicular to N, but T not marked perpendicular to any of them. So I cannot assume that they are. All right, let's go to the last page. Finding distance from a line. We've done distance before. So here it tells me that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So now we're looking at distance from a point to a line. This perpendicular segment is the shortest distance between the point and the line. For example, the distance between point A and line K is AB. So in this first picture, see, and we're talking about the shortest distance. Like I could find the distance from A all the way to K this way, but we see that that is going to be much longer. So we're saying that the shortest distance, right here, the shortest distance between the point and the line is the perpendicular line. Distance between two parallel lines, so now this next picture, is the length of any perpendicular segment joining the two lines. For example, the distance between line P and line M would either be CD or EF. Again, I could find the distance from, let's say, C to F. That is going to be longer than from C to D. So we're looking for the shortest distance. Recall our distance formula. Yes, that's back. Is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Remember that we've also used Pythagorean theorem, a squared plus b squared equals c squared to find distance. All right, so last two examples. It says find the distance from point A to line C. Round your answers to the nearest tenth. Okay, so in this picture, very first thing that I need to do is find the slope of line C. So I want the slope of line C. So this goes back to our very first lesson on slope, counting the points. So let's see, I have a point here. My next point on a nice square is right there. I can tell from left to right, my line is decreasing. So this is like us on our little bicycle, just cruising down that hill. So how far down and over? So I had to go down 1, 2, over 1, 2, 3. So my slope is negative 2/3. So now I want the perpendicular slope because I have to draw the perpendicular line from point A to line C. Remember that perpendicular slopes, you flip them and change the sign. So it's the negative reciprocal. So the slope of line C was negative 2/3. So change the sign of it. I make it positive and flip it and I get 3/2. So point A, I'm going to do my perpendicular slope up 3 over 2, up 3 over 2 until I hit line C. So 1, 2, 3 over 2, right there is where it's going to hit. I know this is perpendicular. So now I can find the distance of A, and we'll just label this B. I can do this two ways, either distance formula or Pythagorean theorem. I will show you both ways to prove to you that it doesn't matter which way we do it. So if I do distance formula, the 2 points I'm using, A, so the ordered pair of A would be 1, negative 2. And then B, that pair is 3, 1. So if I did distance formula, that's equal to the square root, x2, which was 3, minus 1, quantity squared. Now do the same thing with my y's, plus 1 minus negative 2, quantity squared. So that's just plugging those points into the distance formula. Now we want to work this out. Distance is equal to, so the square root, 3 minus 1 gives me 2, and then I have to square it, plus 1 minus negative 2 turns to 1 plus 2, 3, I have to square it. That's equal to 2 squared is 4, 3 squared is 9, 9 plus 4 is 13. So I have the square root of 13. But the directions asked round your answers to the nearest tenth. So I need to plug that in my calculator. So the square root of 13, nearest tenth, that is 1 decimal place. So I get 3.6. So approximately 3.6, and then I found distance, so I need units. So now let's see if I wanted to do Pythagorean theorem. So if I wanted to do Pythagorean theorem on that, to find the distance from A to B, I need to make my right triangle. So I'm just going to drop my line down and over. So this is 2 squares. This is 3 squares. I'll call this C, what I'm looking for, my hypotenuse. So I would say C squared equals 2 squared plus 3 squared. And see, that's exactly what I had underneath the radical, my distance formula. So I get C squared equals 4 plus 9. C squared equals 13, but I don't want 13. Or sorry, I don't want C squared, I just want C, so take the square root of both sides. So C is approximately 3.6 units. You see, it does not matter, distance formula or Pythagorean theorem. We get the same answer either way. Let's do another example of that. So number 24, I want to find the distance, the shortest distance from point A to line C. Again, that shortest distance is going to be the perpendicular line segment between the two. In order to find that line segment, I first need to find the slope of line C. So the slope of line C, I've got a point here. My next point is here. Again, from left to right, I see that it is decreasing. So we are on our bike, just cruising down that hill. So I know my slope is going to be negative. So I had to go down 2 over 1. So my slope is negative 2 over 1, which is just negative 2. So my perpendicular slope, change the sign, so it's going to be positive, and I flip it. So if I flip 2, I get 1/2. So from point A, we're going to do the slope up 1 over 2, up 1 over 2. I have not hit line C yet, so go up 1 over 2 again. So there, and then draw that perpendicular. I can label that point B. Again, I will do this one both ways for you. So point A is at negative 2, 1. Point B at 2, 3. If I do the distance formula, distance is equal to the square root. Subtract my 2 x's. So 2 minus negative 2, and then square it. Plus subtract my 2 y's. 3 minus 1 squared. So I get the distance is equal to 2 minus negative 2 turns to 4, and then I have to square it. Plus 3 minus 1 is 2. I have to square it. 4 squared is 16. 2 squared is 4. So I have the distance is equal to the square root of 20. Again, they asked for nearest tenth, so plug that into our calculator. So the square root of 20 is approximately 4.5. We found distance, so we need units. We can go back and do that by Pythagorean theorem as well. So if I go back and do Pythagorean theorem, again, drop my line and over. So I have 1, 2, 3, 4 squares and 3 squares. So I would say C squared equals, oh, sorry, this is not a 3 up here, is it? It's only 2 squares. 2 squares. So 4 squared plus 2 squared So c squared was 16 plus 4, which is still 20. So I have c squared equals 20, but I don't want c squared, so take the square root, and I get c is equal to, or approximately, since we're approximating, 4.5 units. All right, that is the last section of Chapter 3. Tomorrow we will look at test review, and then Thursday and Friday we will take the test. Remember that I am breaking up the test into 2 parts. Thursday will be over sections 3.4 to 3.6. Friday's test will be over sections 3.1 to 3.3. Your homework tonight is on Canvas. It is called 3.6 homework. So it's in Canvas. You will complete it in Canvas, and then when you are done, your grade will automatically show up for you there. All right. I should see you guys tomorrow.